Hello student, how are you all? I hope you all are doing good and you all are fine. Yes. Okay, so today we are going to start a new topic, and the name of the topic, first of all you have to see what we are going to study. The first slide itself. Now see the image in front of you and you have to tell me what can you see here. I will give you 30 seconds to observe this image, and then you have to tell me what is the magnetic effect of current. Okay, so yes. Yes student, are you thinking? Who will tell me? Okay, so student, we all have studied about the different type of symbols that is used in the electrical appliances. Okay, why we are using this symbol? Because every time we cannot draw the complete picture of battery, bulb, wire. Okay, so we are using the symbol. Okay, and hope you have remembered this as we have discussed in the previous class also. So see student, in the picture 1, and this is, let's say, picture 2. Okay, here we can see that this circuit is open circuit. Okay, because we can see that this is not closed, so this is a open circuit, and this is a battery. Okay, and here it is a magnet. Okay, and it is having a north pole and south pole. So in the pic 1 you can see the circuit is open. Okay, now tell me what you can see in the circuit 2. Now this we can see here, it is closed, so we can say circuit is closed. Okay student, now they what difference you can see in the picture 1 and picture 2 in respect to the magnet? Can you see some difference in the movement of magnet? Yes student, so we can see that once this circuit is closed, means the current starts flowing from positive terminal. Okay, now when we see this magnet earlier was in this direction. Okay, and when the current flowed through the wire, what happened? There was some movement shown in the magnet. Okay, so what conclusion you can make from this? Because earlier there was no current, so magnet was in this condition, and when the current flowed through the wire, we can see there was movement in the magnet. So why this magnet showed the movement? What can be the required reason? Yes students, who will tell me? Yes, you are right student. So because we know that the same polarity of magnet will repel each other, so north pole will repel each other. So can you think that this side of wire has developed one pole, that may be north pole, and this pole, this side, may have developed south pole? So basically student, due to the flow of current, okay, there is the production of magnetic field in the circuit. Okay, anywhere if you have kept this magnet, then that magnet would have shown the deflection. Okay, so due to the pole formation in the circuit, the magnet shows the deflection. Clear? So the topic itself says the magnetic effect of current. That means when a current flows in a circuit, there is a magnetic effect seen in that circuit. Okay, so this is the thing that we have to study. Okay, so let's see the other thing. So just now we have discussed that if the electric current passes through a wire, then the current carrying wire behaves like a magnet. This phenomenon is known as magnetic effect of current. Okay, student. So what is magnetic effect of current? Yes, who will tell me? Yes, if the electric current passes through a wire, okay, then the current carrying wire behaves like a magnet. This phenomenon is known as magnetic effect of current. Okay, so see student, this person is, his name is Hans Christian Ørsted. What is his name? Hans Christian Ørsted. Okay, so he found that when electric current is passed in a wire, then the compass needle placed near it got deflected from its usual north-south position. Okay, so he was the first person to detect that magnetic field can be produced by current carrying wire. Okay, so what is the name of the scientist, student? Hans Christian and Ørsted. Hans Christian Ørsted. Okay, so he was the discoverer of magnetic field in a current carrying wire. So moving to the next part, students. So now you have to think the different ways to increase the magnetic effect. How we can increase the magnetic effect in a circuit? Yes, who will tell me? By observing this also you can see here. Okay, so to increase the magnetic effect, what should we do? We should first of all we should make more number of coils. Okay, more number of coils. And the second most important thing is that to increase the magnetic effect, that coil if we keep in any iron material, okay, if this coil is wounded around a iron material, then the magnetic effect will also increase. Is it clear, students? Okay, so let's see. A straight wire carrying electric current produces the magnetic effect. The magnetic effect is increased only if we use long coil of wire instead of straight wire. So coil of wire is wounded around an iron rod, and then current is passed. So there is simple concept that if we want to increase the magnetic effect, then we have to increase the number of coil. And other thing we can do, we have to wound it around the iron rod. Is it clear? Yes. Now you have to answer this question. Magnetic effect of current was discovered by dash. Ørsted, William, both or none. So student, you have to tell the answer. I will give you 30 seconds to recall the things, and one by one you have to tell me. Everyone has to say this answer. Who discovered the magnetic effect in a circuit, closed circuit? Yes, students. So correct answer will be Ørsted. Okay. So moving forward, now what we are going to discuss, the usage of magnetic effect. Okay, in what way we can use the magnetic effect in a wire? So we have seen such electrical appliances in our home, that is known as miniature circuit breaker. Okay, and in the short we say MCB. What is it? It is a MCB, student. Okay, so actually this is very similar, or in the earlier days we used to use the fuse. In the board there was one fuse. Okay, and this was on the principle of amplitude of current. Okay, so in the fuse what happened, that when the amplitude of current was increased, this wire melt down. Okay, and it is torn off. But what happens in the miniature circuit breaker is that it does not depend upon the amplitude of the current. Okay, but it depends upon the magnetic effect of current. Okay, so MCB work on the principle of magnetic effect of current. So as soon as the amplitude of the current or magnitude of the current will increase, so the magnetic effect will also increase. Yes or no? Yes, yes, student. So once the magnitude of the current will increase, the magnetic effect of the current will also increase. So what will happen? This will turn off. This will fall down. Okay. Now what will happen? The complete circuit in your home will be cut down. Okay, and your all the appliances like fan, bulb, fridges, printer, computer, all will be saved. Okay, otherwise it would, all the appliances would have blown off. So so again, to make this circuit on, what we have to do? We have to put it on. We have to again press this above. Okay, then again this circuit will be closed, and again the current supply will be evenly distributed in your house. So student, now you have to tell me what I have done, what I have taught you now, and on what principle it works. Okay, and how it is different from fuse. You have to tell that. Okay, so moving forward, student, see, MCB do not work on the heating effect of current, as it work on the magnetic effect of current. Okay, the switches automatically turn off when the current in a circuit exceeds the safe limit. We turn them on and the circuit is once again completed. So when the current will increase, the circuit will come down, automatically the switch will come down, and to again complete the circuit we have to turn it on. Okay, so moving forward, now here also this we have done already. Now you have to tell me MCB work on the principle of dash. On which principle MCB work? I am giving you 30 seconds. It works on the principle of magnetic effect of current. Okay. Now see, student, the other uses of magnetic effect of current. Now you have to tell me what is happening here. I will give you some time also. 30 seconds are there. One by one, everyone has to say what is happening here. You have to mark the flow of current in this circuit, and you have to also tell whether this circuit is open or closed. Okay. So student, look at here. So first of all, the question is that is this circuit open or closed? So this circuit is closed. From which terminal the current is moving? So from the positive terminal. Okay. So tell me, is the iron nail conducting or non-conducting? It is a conducting. Okay. Now the current flowing in this wire will give dash effect. Yes, it will give magnetic effect. So student, we all know that iron is a metal. Okay. So when this wire is wounded around this nail and there is a flow of current also, then this nail will become a temporary magnet. Okay, this nail will become a temporary magnet, and this complete process of making a metal as a magnet is known as electromagnetism. Okay, so who will tell me what is electromagnetism by yourself? Who will make out the definition of electromagnetism? Yes, who will tell me? I will give you time also. Okay student, so electromagnetism is the process through which any metal is made magnet by the effect of flow of current in it. So let's read this. It is a magnet made by using electric current. An electromagnet works on the magnetic effect of current. The electromagnet consists of a coil insulated wire wrapped around a piece of iron which is magnetized only when electric current is passed through the coil. Okay, so once the current passes through the coil, this piece of iron nail will form a magnet. Okay, now students, see, there are two factors through which an electromagnet can be made strong. Okay, so the first one is by increasing the amount of current used in the coil. Okay, so if 2 ampere is used as a current, if 4 ampere is used and 10 ampere is used. Okay, so in which of these three conditions there will be more electromagnet? So yes, in the 10 ampere coil, then in the 4 ampere coil, then in the 2 ampere coil, by increasing the number of turns forming the coil. Okay, so this was the nail, and if we have only 80 coil here, and in this nail if there is 100 coil. Okay, so in 100 number of coil there will be more electromagnetism. Okay students, are you understanding this factor? Now you have to tell me what are the two factors through which electromagnet can be made stronger. Okay, so you have to tell me one by one. Yes, so students, say by increasing the number of current used in the coil and by increasing the number of turns forming in the coil. Now student, it's now your turn. The strength of electromagnetic effect can be increased by increasing the current, increasing the number of coil turn, both or none. So just now we have studied, but still I will give you some time. Everyone has to tell me the correct answer. Yes. Good. Good students. Very good. Who will tell me? Yes, both. Now in today's class we have studied about magnetic effect of current, miniature circuit breaker and electromagnetics. So now we will recapitulate the few questions here. When the current passes through the wire, a magnetic effect will be seen. Yes, it is true. Miniature circuit breaker, that is MCB, work on the principle of magnetic effect of current. An electromagnetic consists of coil insulated wire wrapped around a piece of iron which is magnetized one. An electric current is passed through this coil. So this is a electromagnet. It is a true statement. So students, now you have to do this homework. Make a chart of magnetic effect of current, MCB and electromagnetics. Now you have to paste the picture of your MCB that is present in your house. Okay, I want to see that picture. So okay students, this is the last part of our lecture. We will meet in the next session. Till then, happy, be safe. Bye bye everyone. Take care.